This is WAEC June 2020 General Mathematics Paper 2, and we are answering question number 12A, and the question reads in the diagram. Line AB is a tangent to the cycle, and that cycle has center at O. This is line AB, and this is the cycle. The center of that cycle is at this point O. So AB is a tangent, which means it's a straight line touching the cycle at just one point. You can see here it is at the point A. The line AB is touching the cycle. The question further says COB is a straight line. COB, this is a straight line. And if line CD, look at line CD and line AB are parallel, you can even see the two arrowheads there indicating that these two lines are parallel. And angle ABE is 40 degrees, is marked in the drawing. So what you asked to find is the size of angle ODE. ODE. This is the angle that we asked to find its size. So let's attempt to answer this very question together. Solution to the problem. Usually, you cannot find the angle asked to find it directly. You have to have some other angles that will lead you or enable you to find that angle ODE. So looking at the drawing, we have this angle 40 degrees, angle ABE. And I have a line AB parallel to line CD. This is the only information that we can see exactly from this very drawing. So looking at this drawing critically, what angles do you have to find so that it in the end it will lead you to find angle ODE. Let me start with angle OCD. OCD, this very angle. This angle and angle ABE are alternate to each other because these two lines AB and CD are parallel, and line CB now serves as a transversal. So this angle ABE and angle OCD will now be alternate to each other. Therefore, angle OCD will now equals to angle ABE and will now be equals to 40 degrees. And a simple reason, the two angles are alternate angles, and alternate angles are equal. So let me mark it in the drawing. This is angle 40 degrees. So I continue. So next angle that I will now find that enable me find angle ODE is angle ODC. ODC. Looking at the drawing, from O to C is a radius, from O to D is another radius. And the triangle OCD would now be an isosceles triangle because two of its sides are equal. These two radii are equal. So this is an isosceles triangle. A theorem says base angle of isosceles triangle are always equal. So angle OCD and angle ODC would now be base angles. So therefore, angle ODC would now be equals to angle OCD, and it will now be equals to 40 degrees. And the simple reason, they are base angles of isosceles triangle. So I continue. Going back to drawing again, line COE is a diameter. It passes through the center O. And it is this chord CE that subtend angle CDE at the circumference. So remember theorem which says angle in a semicircle is 90 degrees. Therefore, angle CDE would now be 90 degrees. And my simple reason, it is angle in a semicircle. So if I have the whole of this angle CDE as 90 degrees, and I have this small angle ODC as 40 degrees, I can now use the two to find angle ODE by simply subtracting 40 degrees from 90 degrees. What remains will now be angle ODE, and that is the angle we asked to find. Therefore, angle ODE will now be equals to 90 degrees minus 40 degrees, and subtracting 40 from 90 correctly gives a result 50 degrees, and that answered the question. So let me just share with you quickly the mark distribution for this very question as it is there in the marking scheme. So the very first mark is bonus 1 mark, and this bonus 1 mark is for having angle OCD as 40 degrees. Exactly, you have bonus 1 mark. Next mark is another bonus 1 mark for having angle ODC correctly as 40 degrees. You have bonus 1 mark again. Next mark is attempting to find angle ODE by subtracting 40 from 90 degrees. You have this method 1 mark. And when you now subtract it correctly and you have angle ODE exactly as 50 degrees, you have accuracy 1 mark. So if everything is done correctly in this question, you now have 4 good marks.